So let's look at how to solve an initial value problem, which means we were given a differential equation and a certain condition, an initial condition, and that is the initial condition, which means that when the independent variable, which is t in this case, when t is 0, y is going to equal 3. So after we solve, we'll get a c value, and then after we can plug this stuff in to figure out what that c value is. Okay, so the variables that we have are t and y, so we first try and separate them. They're already multiplied together, so that works. But I want to change my y prime to a dy dt. That way I can separate the differentials. So I'll do that and then multiply both sides by dt. That's what I'm thinking of it as. Then I get dy equals negative ty dt. And from there, I can, well, further separate. And I'll do that by dividing both sides. Well, I want to keep my t's over here, so I'll divide both sides by y, which means I'm multiplying by a 1 over y. So then I get this, and now what I'm going to do, because this is a part that we haven't gotten to yet, so this is the new part. But it looks like these are the starts of integrals, so I'm just going to integrate both sides. So there we go. I'll integrate both sides. Now what I'm going to do, well, the left side, that's just ln of y, and there's something that we're going to be doing with that. We'll eventually exponentiate both sides. And then this one would be negative t squared over 2 plus c. Notice I didn't write the plus c over here. If I did, plus c, that's just some arbitrary constant. I don't know what it is. I have no idea. I could have a plus c, maybe call this c1 and this c2. And then I could subtract c1 over on this side. And I would get, I don't know, whatever c2 minus c1 is. That's just, I don't know, c3. So I'm going to say plus c3. It's still some arbitrary constant. So I would eventually just have something like this. Right? And then some random constant. But what we do for convenience sake is we just realize that this is going to happen every single time. On the left side we'll get a plus c, on the right side we'll get a plus c. That's because we have indefinite integrals here. But I know that they're going to combine together to create some other c value, so what we do is instead of doing all of that, we simply don't write the plus c on the left side. So this you can write the plus c only on the right side for simplicity. So that's what happened there. Now technically this is a solution, but I want to solve for y, so we're going to do some other tricks. So let me reiterate. Yes, these are both indefinite integrals, and you would get a plus c over here, but to keep it simple, we only write the plus c on the right side. We can omit it on the left side because we know that they're going to combine and they're going to make another constant. So I'm just going to not write it down every single time. So that's something to get comfortable with. When you're integrating both sides, you can just write the plus c on the right side. I'm saying it a bunch of times so it sinks in your brain. When you integrate both sides, you can just only write it on the right side. It's makes things a lot quicker. Also, this is going to happen a lot. We're going to exponentiate both sides now, which means I'm going to take both sides and raise it to the power of e. So that's all of this to the e. Now, eventually, I mean, I'm going to show the steps here, but eventually this will get quicker. But let's see what happens. So I have ln and e cancel out, so I'm just left with y. And then I have e to the negative t squared over 2. And then plus c. Now, normally I wouldn't write that. I would just write this. Right? Because if I have the same base, I just multiply. Actually, I wouldn't even write that. I would actually just change this. E to the c, this is the same type of trick as up here. Same type of trick. E to the c, well, c is just some constant, is some other constant. E to the 30, or I have no idea. It's just some constant. I don't know what it is. I have no idea what that constant is. But it is just some other constant. So what we do is we treat this as c, also for simplicity's sake. And I'm going to say it again. E to some random constant is still just some random constant. And we're multiplying this times this. E to the c is just some random constant. So I'm going to change e to the c into c. It kind of like it's like a shapeshifter. That's what some people say that's how some people think about it. But hopefully you understand that it doesn't matter whether I have e to the c and I don't know what c is, or I just have c and I don't know what c is. Because e to the c could be any number except for 0. So we know that c here is not 0, but c here could be 0, but that changes it to 1. So hopefully, I'm saying it again and again and again, hopefully you understand that e to the c is some constant. So really what I'm going to do is I'm going to write y equals capital C times e to the negative t squared over 2. I'm hoping that doesn't kill your brain. So we did 2 tricks here. First, we only wrote the c on the right side because it's going to come out to be some other constant anyway. And same idea for this. When we exponentiated both sides, we just changed the e to the c into just a constant. So hopefully you understand that. If you don't, please rewind it and see it again. Maybe it'll click the second time around, because I've been repeating it a bunch. But all right. So this is called a general solution to this, but we have initial conditions that'll help us figure out what this c value is. So we're going to use the initial conditions. Once we figure out what c is, we can plug it back in, and then it's called a particular solution. So right now this is a general solution because we don't know what c is. C could be anything. But depending on the initial conditions given, it determines what c is. So we're actually going to use these. Y equals 3 when I plug in 0. So I'm going to plug in 0 to this. So I get e to the 0, which is just 1. So y equals just c, but y is 3. So hopefully you understood that.